Hi, this is Mrs. Yamamoto, and today we're going to continue talking about different properties of exponents. In our first example, we're going to talk about the power of a power. In original form, our first example is 5 squared raised to the 5th power. So what does this look like in factored form? Well, we know that 5 squared is the same as 5 times 5. So if I have 5 squared to the 5th power, that means that I'm going to write 5 times 5 5 times. So now that I've written out my factored form, let's look back at our original question. Our original question said that we have 5 squared to the 5th power, so we wrote that in factored form 1, 2, 3, 4, 5 times. And if I want to simplify this, what I have to do is figure out, well, how many 5s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this in simplified form is 5 to the 10th power. Notice that in my original question, my exponents were 2 and 5. And 2 times 5 gives me 10, which is my exponent in my simplified form. In my next example, let's look at x to the 3rd power raised to the 4th power. So I know that x to the 3rd power in factored form would be x times x times x. So that's x to the 3rd. So if I want to write my original form in factored form, I would write x times x times x 4 times. And so I have this 4 times. And altogether I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So in simplified form, I have x to the 12th power. Notice that 3 times 4 gives me 12. So the power of a power rule states that we need to keep the base the same and we multiply the exponents. So algebraically that would be denoted, let's say, with a base of a that was raised to the mth power, and then to the nth power would be a to the m times n. So in our first example, here my base is 8, and I have 8 squared to the 3rd power. So this would be 8 to the 2nd power times 2, which would give me 8 to the 6th power. So notice, a power of a power rule states that we multiply the exponents. Go ahead and see if you can solve example 2, and we'll check that answer in class tomorrow. Next, we're going to look at the product to a power. In original form, we have 5x squared raised to the 3rd power. So I'm going to write that in factored form. So 5x squared in factored form would be 5 times x times x. And since that is raised to the 3rd power, I'm going to write that 3 times. And in simplified form, let's see, I have 5 3 times, so that would be 5 cubed, and then I have how many x's? 1, 2, 3, 4, 5, 6 x's. So that would give me x to the 6th power. Let's try another example. Here I have x squared. X squared is x times x. Y squared, y times y, and z cubed, z times z times z. And this is raised to the 2nd power, so I'm going to write that 2 times. So I factored out my expression. Now I just want to simplify. So let's see, I have 1, 2, 3, 4 x's, so x to the 4th power. Then I have 1, 2, 3, 4 y's, y to the 4th power. And lastly, I have 1, 2, 3, 4, 5, 6 z's, so that's z to the 6th power. So looking at my answers from my original form and my simplified form. So my simplified form, this is like my answers, right? And what happened? What did I apply? So the product to a power rule states that to raise a product to a power, we're going to distribute the power to each factor. So you see that 3 was distributed to the 5, and then 3 was also distributed to the x squared. 2 was distributed to the x squared, 2 was distributed to the y squared, and 2 was distributed to the z cubed. So let's go ahead and write this algebraically. Here if I have a times b to the mth power, that gets distributed to both. So I would have a to the mth power times b to the nth power. So here in my first example, I have 4x cubed raised to the 2nd power, so I'm going to distribute. So one thing I want to make a note of here is that if I don't see an exponent, the exponent is 1. So here 2 times 1 would give me 2, so my first part of my term would be 4 squared, and the 2 comes from multiplying the 1 and the 2. And next I would have x to the 6th power, and the 6 comes from multiplying 2 and 3. So my answer for example 1 is 4 squared times x to the 6th. See if you can solve example 2, and we'll check your answer tomorrow in class. Alright, third thing we're going to look at is the quotient to a power. So here in the quotient to a power, first we have x cubed. X cubed broken down would be x times x times x, and then y to the 4th. Y times y times y times y. So since I see I have an exponent of 2, I'm going to write this 2 times. So that's in factored form. In simplified form, I'm going to count how many x's do I have. I have 6 x's, so that would be x to the 6th. And then how many y's do I have? I have 8 y's, so that would be y to the 8th power. So notice that the 2 gets distributed to both the numerator and the denominator, to the power on the numerator and the power on the denominator. Alright, let's go ahead and look at the next example. Here I have x squared times y squared on my numerator, so that would be x times y times y, and I would have that twice. And on my numerator I would have my denominator I would have z to the fifth, so that's 5z's. So that's the factored form. Now I want to go ahead and simplify this. When I simplify, I simply take a look and see, okay, it looks like I have 4 x's, so that's x to the fourth. I have 4 y's, y to the fourth. And on my numerator, I have 10 z's. So to raise a quotient to a power, the rule states that I distribute the power to the numerator and to the denominator. Algebraically, let's say I had a over b raised to the mth power. That means that my answer would be a to the mth power divided by b to the mth power. So in our notes today, notice that the factored form gives us a nice visual of where the simplified form comes from, but if you remember the rules, you do not have to write the factored form each time. So in our example here, I'm going to distribute the power to the numerator and to the denominator. That would give me m to the 10th power divided by n to the 6th power. So go ahead and try example 2 and we'll check that in class tomorrow. Last thing we're going to talk about is something called a zero exponent rule. It's very simple and straightforward. Any number raised to the 0 power is equal to 1. So let's say I have a to the 0 power. A could be any base, and my exponent is 0. Then that is always going to be equal to 1. So for our first example, 5 to the 0 power is equal to 1. Anytime you see 0 in an exponent, that would be equal to 1. Go ahead and try example 2, and we'll check that in class tomorrow.